Hello, so in this video we're going to see three more example derivations, three examples of indirect derivations, basically, where we're going to be using ID. Okay, so we're starting with this one, and so we'll say show conclusion, and we notice there are no premises, so okay, it's a theorem. We've seen these before. This is a sentence that's true no matter what, can be derived without relying on any claims, any other sentences. So we say, well, let's make an assumption. And I think, okay, we'll go ahead and say assume ID. And you go, wait a minute. What can I do with line 2? 2 is a negation. It's a negation of a conditional. So well, I can apply dn, and that's pointless. The problem here is that we've made the wrong assumption. Right? We always want to make an assumption, and we've been in the habit of, in the last three problems, in fact, we did assume ID. But we want to remember that the directions about when to make which assumption say, if you can make a conditional assumption, do so, and only make an indirect assumption if you cannot. So in this case, we're going to say assume CD, because what we're trying to show is indeed a conditional, right? And so we can do assume CD, and when we can do assume CD, we want to. And in fact, if we do assume CD, or assume ID, when we could have done assume CD, we're not going to be able to complete the derivation. So usually, in most cases, if you apply a rule, it's not going to mess up your derivation. It'll just give you an extra line. In this case, you can actually go in the wrong direction that you can't recover from without deleting that line. If you're showing a conditional, and you may need to do assume CD, and if you do assume ID instead, you will not be able to complete the derivation. So, if you can, do assume CD. Okay, so having completed our first two steps, showing the conclusion and making an assumption, we now want to do our third step, which is to bring in any premises. But as we already noted, there are no premises, and so the third step is already done. So we move to our fourth step, which is to apply our inference rules. And if we look and see, well, unfortunately, there's nothing we can do. We could apply double negation to 2, and that will be pointless. We can't do MP or MT with line 2, so there's nothing to do with the inference rules. Can we box and cancel? No, we would need either this whole big conditional for DD, which we do not have, this negation for CD, it's a negation of a conjunction, but it's a negation for CD, or we need a contradiction for ID, and we don't have a contradiction. So the derivation is stuck. No inference rule applications available, no way to box and cancel, and that means we need to do a sub-derivation. What sub-derivation should we do? One that will help us complete the derivation as quickly as possible. What will allow us to complete the derivation as quickly as possible is boxing and canceling line 1. We started with assume CD, so probably we will box and cancel with CD. What do we need to box and cancel with CD? We need the consequent. We need, that. So that's what we want to show. Once we get the consequent, we'll be able to box and cancel the whole thing with CD. So we're going to try to show the consequent, and we will use our show cons command to do so. Okay, we have a new show line now. Whenever you have a show line, you want to make an assumption, as we learned in the sub-derivations module. And you want to make the right kind of assumption. So there are two kinds of assumptions we have, CD or ID. And our strategy says if you can do CD, if you can do assume CD, do that. Otherwise, do assume ID. Well, line 3 is a negation. It's not a conditional, so we cannot do assume CD with line 3. So that means we need to do assume ID, and that's what we'll do. So say assume ID. And so now we've made two assumptions in this derivation. One is assume CD on line 2. One is assume ID on line 4. So that means we're currently working on line 3, and having made this indirect assumption from line 3, right now we're thinking indirect derivation because we're working with an indirect assumption. Once we complete box and cancel line 3, we're going to be back to thinking, okay, I probably want to box and cancel with CD, and in fact we will. That was the point of showing line 3. But in general, you want to be thinking, okay, I want to be boxing and canceling, but how? Well, with whichever was the most recent assumption, probably. The most recent assumption in this case is line 4, assume ID. So we want to look in the first place for a contradiction. If something else shows up, great, but we want to keep our eyes out for a contradiction. Okay, with that, thinking about where we're going in place, now let's start moving. So we want to apply our inference rules if we can, and indeed we can. We can apply inference rules to line 4, because 4 is a conjunction, and so we can apply simplification left giving us P, and simplification right giving us not Q. And now we want to see, can I use either of those with line 2? And indeed you can. In fact, you can use either of them. You could say 25MP, or you could say 26MT. So if we say 25MP, we'll get Q. And oh look, we have what we need for contradictions 6 and 7. To get that contradiction, we needed to do both simplifications, one for the MP and then one for the contradiction, and we'd say 6, 7 ID. We could also instead, after doing both simplifications, apply MT to lines 2 and 6, and that would give us not P, and again we could have a contradiction, this time with P and not P. So either way, whether we use P for MP with line 2 or negation Q for MT with line 2, we'll get a contradiction, and that's an illustration of the general idea that when you are working under an indirect assumption, you are probably going to have multiple routes to get to a contradiction. So we saw that here. So now we've completed line 3, but we're not done with the derivation. But now, having completed this subderivation, we want to see, well, can I use it? Because almost always, not always, but almost always, once we complete a subderivation, we can. And indeed, in this case, we can. And if we aren't sure why, well, we always want to look over here at our show command. And this is show cons, and that tells us that line 3 is the consequent of the previous show line. And so we've gotten what we now have on line 3 is the consequent of the previous show line. When you have a show line, that's conditional, and later you have the consequent, then you can apply CD to the consequent to box and cancel the main line. So we'll say 3 CD, and that completes the subderivation. Or excuse me, the derivation, not the subderivation. We already did the subderivation. So though there's this derivation, and what this shows is a couple of things. When you're doing indirect derivations, there may be subderivations, and actually when you're doing conditional assumptions, there may be subderivations. So you want to remember for each line, now I should be making an assumption no matter what. It might be superfluous, but let's not take that risk. Let's always make an assumption. We'll do assume CD when we can, and assume ID when we can't do assume CD. And we want to be paying attention to whichever kind of assumption we've made most recently, because that tells us what we should be looking for. If we've most recently made an assume CD, we should be looking for the consequent of our conditional that we are trying to show. If we made an assume ID, then we should be looking for a contradiction. Okay, let's take a look at another problem. So, show the conclusion. Okay, we want to make an assumption. We cannot make a conditional assumption, so we'll make an indirect assumption instead. Good. Now we'll bring in our two premises. We want to apply our elimination rules. Well, there's that conjunction, so let's split it up. Let's see if we can use lines 5 and 6 with 3 and 4. Yes, we can. Line 3 is a conditional. Its antecedent is P, so we need P for modus ponens, and we have that on line 5. So we can say 3, 5, modus ponens. We get Q. Now, so we've used 2 and 3. Now we want to see if we can use 4. And there are actually two things we can do with 4. We can do modus ponens with 4 and 7, or we could do a double negation with 6, and then do MT. So let's first do it with the modus ponens way. So we'll say 4, 7, MP, and we get not R. Oh, hey, we have a contradiction with 6 and 8. So we're done. That's pretty nice. But we also instead could have said, oh, well, look, there's 6 on line 6. I have R for modus tollens. For MT with line 4, I need negation R. I can get negation R. So I can say 4, 7, MT. Have not Q. Oh, I deleted too much. Whoops. Let's try that again. Okay, so we had P and we had R, and then we had done modus ponens 3, 5. There, good. Sorry. So now let's use 6 with 4. So we say 6DN, and then we say 4, 8 MT, and we get not Q. And no, there's another contradiction, 7, 9 ID. So in the previous one, we had a contradiction with R and not R. Here we have a contradiction with Q and not Q. So you can see that there are different, when you are doing an indirect derivation, there are going to be different ways to get to different contradictions, and any are fine. As long as you get to a contradiction, that's all you need, you're good to go. Was it the quickest? Was it or not the quickest? Who knows? Was it the best contradiction? There is no best contradiction. All contradictions are as good or as bad as any others. So, just to see that there are different ways to get contradictions. Okay, let's go ahead and do our last example problem. So, we'll start with show conclusion. We always want to make an assumption. In this case, we cannot do assume CD, so we're going to say assume ID. So here we go. And we'll assume Q. When you have the option between, let me actually just show you that again. So when you are showing a negation, you always have the option of showing the unnegation or the double negation. Right? We're trying to show not Q, so we can either show Q. Well, we can either assume Q or negation Q. I would recommend in general doing the one without the negation. You might want this one. You can always go back and forth between them, but you're more likely to use this one than you are that one. Okay, so we've assumed Q. Now, step 3, we bring in our premises. So let's bring in premise 1, premise 2, and premise 3. Okay, so we look at what we've got here. We have Q on line 3. Let's parse line 3. So line 3, the main connective might be the conditional, or it might be the conjunction. It's the conditional because we remember that arrows always go above wedges, above ands. So this is the main connective. This is a conditional whose antecedent is P and Q. So here we have we want to try to do MP or MT with this. So we could go for MP. For MP, we would need P and Q. We could go for MT, and we would need not R. So, okay, well, in fact, there we have not R on line 4. So let's go ahead and say 3 for MT. Now we have negation of P and Q. So now we have Q. We've used line 3. We have not R on line 4, which we've used. We might use again, and we have P on line 5. So in terms of rules, at this point, we're kind of stuck. We want to look to see if we can box and cancel. Well, for DD, we would need negation Q, which we don't have. For CD, not going to apply because we're not trying to show a conditional. What about ID? Do we have any contradictions? We do not. But we're very close to finding one because line 6 is a negation of P and Q. So what is the contradiction of line 6? So the contradiction of line 6 is this. The contradiction of line 6 would be P and Q. If we could get P and Q, we would have a contradiction between line 6 and 7, because we'd be saying negation of P and Q on line 6, and we'd just be saying P and Q on line 7. So we'd be saying negation box on line 6 and box on line 7. That's a contradiction. Those, one of them always has to be true and the other always has to be false. They always disagree. Okay, well, in fact, we can get P and Q because we can, with 5 and 2, we have P on line 5 and Q on line 2, so we can apply a join. We can adjoin P with Q, and we will get, and we want to choose P and Q, our contradiction, and there it is, 6, 7, not modus ponens, 6, 7 ID, and there's our contradiction. Okay, so sometimes the contradictions might be complex, they might be big. So once you, in particular, when you have, if you see something like this, I'll have a negated, then I have a complex statement, not just a sentence letter, but not an atomic sentence, but a more complex sentence, and then the negation of that. Then you think, okay, what am I going to do with that? Oh, that will probably be half of my contradiction. What I need to do is get the unnegation. I need to get the complex statement by itself. So here the complex statement is P and Q. And it's the negation of P and Q, so we want to get the P and Q by itself, the complex statement by itself. Doing that, we can then apply ID. And the parentheses are missing here on line 7 because the computer likes to drop the parentheses whenever it can, and it doesn't need them on line 7. But still, line 7 is the contradiction of line 6. So that's how to do this. I'm going to show you now a different way to do this derivation instead of the MT application, just because it illustrates a point that's worth seeing. Oh, whoops, we need premise 3 there. Okay, so with line 3, we see, well, we just did MT using 3 and 4. But we could also do, for modus ponens, we need P and Q. And as we just saw, we can get P and Q. We can say 5 to adjoin again. We'll build P and Q. We can apply modus ponens to 3 and 6. That gives us R. And now we have a contradiction between R and not R. So you can run the contradiction through the conditional either way. You can run it through using modus ponens, and then you get where you otherwise have the contradiction of the consequent, or you can run it through using modus tollens, where you otherwise get the negation of the antecedent. Either way, when you're in ID, what often happens is you can either go from get this, go to there, and then you get a contradiction with that, or you get the negation of this. Using MT, you get the negation of that, and then you get a contradiction of the negation of that by somehow or other also getting just P and Q by itself. Okay, so that's how you would do this problem. So we've seen a bunch of examples with ID. Main things you want to remember, always make an assumption. Assume CD if you can, assume ID otherwise. Once you've made a particular kind of assumption, until you work on getting the associated kind of material you need for boxing and canceling. So if you've done assume CD, try to get the consequent of the conditional you're trying to show. If you've done assume ID, try to get a contradiction until you enter a new assumption if you're doing a sub-derivation, and then you want to work with that assumption. And remember that there are often different ways through an indirect derivation. Okay, so that's what you need to know. You're ready to go and do the homework. If you do have any questions, please let me know. Good luck.